Hello learners! How are you today? I hope you're always at your best to learn new ideas in general mathematics. I'm Teacher Judy, your math learning buddy, your guide as you explore the inverse of one-to-one function and its representation. Are you ready? Get your pen and learning activity sheet and let's start.
The most essential learning competencies to discuss for this lesson are the following. Represent real-life situations using one-to-one functions. Determine the inverse of one-to-one function. Represent inverse function through its table of values and graph. Find the domain and range of inverse function. Graph inverse function and solve problems involving inverse functions. Our main objectives of this lesson are the following. Illustrate one-to-one function. Identify one-to-one function. Illustrate horizontal line test. Solve the inverse of one-to-one function. State the properties of inverse function. Represent inverse function through its table of values and graph. And find the domain and range of an inverse function. From the previous lesson, you have learned about function. Now, before we start the new lesson, let's have a warm-up activity. Letter A. From the groups of elements, which of the following mapping diagram represents a function? Is it the function of f, the function of h, or the function of g? The answer is, it is the function of f and g, because each value of y in y groups of elements is unique for a specific value of x. Letter B. Given 5 samples of situations, identify whether the given situations represent one-to-one function. The relation pairing the LRN2 student. The relation pairing a real number to its square. A set of elements 3 and 1, 4 and 2, 3 and 2, 1 and 2, and 5 and 4. A set of elements 2 and 2, 4 and 4, 3 and 2, 5 and 7, and 1 and 4. A set of elements 1 and 2, 3 and 4, 5 and 6, 7 and 8, and 9 and 10. The answer is, it is item numbers 1 and 5 represents a one-to-one function since each student has a unique LRN, and in item number 5, there is no y value which is paired with the same x values. Let's start with lesson 1. Study the definition of one-to-one function. A function is one-to-one if the value of x sub 1, x sub 2 is in the domain of function. Then, the function of x sub 1 is not equal to the function of x sub 2, meaning the value of y is never paired with two different values of x. There is a tool to determine a one-to-one function in the graph, the horizontal line test. Applying this tool, all one-to-one functions satisfies both vertical and horizontal line tests. Now, apply the horizontal line test by comparing the graph of function of y which is x cubed and the graph of function of y which is x squared plus 2. If y is equal to x cubed, the graph is asymptotic along the vertical axis. Intersecting the horizontal line within the graph, the line intersects the graph at one point, meaning the graph is a one-to-one function. Now, let's proceed to the graph of y which is x squared plus 2. The graph is a parabola that opens upward. Intersecting the horizontal line within the graph, the line intersects the graph at 2 points, meaning the graph is not a one-to-one function. You are now in Lesson 2, Inverse of a one-to-one function. Let f denoted as a one-to-one function and f raised to -1 denoted as an inverse of one-to-one function. Only one-to-one function has an inverse. If a function has no inverse function, then it is not a one-to-one function. Here are the steps in finding the inverse of one-to-one function. Step 1. Write the function in the form of y which is equals to f of x. Step 2. Interchange the x and y variables. And step 3. Solve for y in terms of x. Applying the steps in solving the inverse of one-to-one function, here is example number 1. Find the inverse of function f of x which is 3x plus 1. So, let's start with the solution. First, change the function f of x to y and y is equal to 3x plus 1. And then, interchange the variable x to y and y to x. From y which is 3x plus 1, interchange y to x. So, x is equal to 3y plus 1. And finally, simplify x which is 3y plus 1 by transposing 1 at the left side. So, x minus 1 is equal to 3y. Solve for y in terms of x by dividing 3 on both sides of the expression. And afterwards, cancel out 3 at the right side so that y is equal to x minus 1 over 3. Therefore, the inverse of function f of x which is 3x plus 1 is x minus 1 over 3. Another example, if the given is the function of g of x which is x cubed minus 2, solve for its inverse. Again, you are going to apply the steps done in example number 1. First, you are going to change the function g of x to variable y. Therefore, y is equal to x cubed minus 2. And next is interchange the variables x to y and y to x. From y which is x cubed minus 2, interchange its variable y to x. So, x is equal to y cubed minus 2. And the last step is, you are going to simplify x which is equal to y cubed minus 2 by transposing -2 at the left side of the expression. So x plus 2 is equal to y cubed. To solve for y in terms of x, you have to eliminate y cubed by applying cube root on both sides of the expression. So the cube root of x plus 2 is equal to the cube root of y cubed. And there, you can cancel out cube root at the right side of the expression. And y now is equal to the cube root of x plus 2. Therefore, the inverse of g of x which is x cubed minus 2 is the cube root of x plus 2. And now, you have the last example. If the given is y which is equal to 2x plus 1 over 3x minus 4, solve for its inverse. Again, following the same procedure, we write the function of y because the function is already expressed in y. Next, interchange the variables x to y and y to x. From y which is equal to 2x plus 1 over 3x minus 4, interchange its variable to x. And x is equal to 2y plus 1 over 3y minus 4. And now, simplify x which is 2y plus 1 over 3y minus 4 by cross-multiplying x and 3y minus 4. And the product is 3xy minus 4x equal to 2y plus 1. And there, you have to group similar terms by transposing positive 2y at the left side. And you have 3xy minus 2y is equal to 4x plus 1. To solve for y in terms of x, factor 3xy minus 2y. resulting to y multiplied to the quantity of 3x minus 2, which is equals to 4x plus 1. And there, you have to cancel out the quantity 3x minus 2. And y now is equal to 4x plus 1 over 3x minus 2. Therefore, the inverse of function y, which is 2x plus 1 over 3x minus 4, is 4x plus 1 over 3x minus 2. This function is not a one-to-one function because this is a quadratic function. From those examples of finding the inverse of one-to-one function, the properties of an inverse of one-to-one function are the following. Letter A. The inverse of x is the function of x. Letter B. The function of inverse function of x is equal to x for all x in the domain of inverse function. And letter C. The inverse function of x is equal to x for all x in the domain of function. There are more solved examples of one-to-one function and its inverse. Number 1. The function of 2x plus 4, its inverse function is x minus 4 over 2. Number 2. The function of 3x plus 4 over 2, its inverse function is 2x minus 4 over 3. And number 3, the function of 3x plus 4 over 2x minus 2, its inverse function is 2x plus 4 over 2x minus 3. From the preceding lessons, you have learned how to use the horizontal line test and how to find the inverse of one-to-one function. This time, you are going to draw the graph of an inverse function. Always remember that the graph is one-to-one if it passes the horizontal line test. Example number 1. Observe the graph of function f of x, which is 2x plus 1 and its inverse. Solution. Change function f of x to variable y. So y is equal to 2x plus 1. Then, interchange the variables x and y. From y, which is 2x plus 1, interchange it to x, which is 2y plus 1. Simplify x, which is 2y plus 1, by transposing 1 at the left side. Solve for y in terms of x by dividing both sides of the expression by 2. Then, eliminate 2. So y now is equal to x minus 1 over 2. Therefore, the inverse of function f of x, which is 2x plus 1, is x minus 1 over 2. After solving the inverse of function f of x, which is 2x plus 1, and its inverse function x minus 1 over 2, then draw the graph. The graph is a straight line. The graph of function f of x reflects on the graph of its inverse function. The graph intersects at -1 at the third quadrant. The domain of the graph are values taken along the horizontal axis, and it is represented by the graph of inverse function. Why? Because the domain of inverse function is wider than the domain of function. And the domain is a set of a real number such that -3 is lesser than or equal to x, then x is lesser than or equal to positive 4. Now, the range of the graph. These are values taken along the vertical axis, which is represented by the graph of function. Why? Because the range of function is higher than the range of inverse function. The range is a set of a real number such that -3 is lesser than or equal to y, then y is lesser than or equal to positive 4. To summarize the domain and range of function f of x and its inverse function, in function f of x, the domain is a set of a real number such that negative 2 is lesser than or equal to x, then x is lesser than or equal to positive 1.5. And the range is a real number such that negative 3 is lesser than or equal to y, then y is lesser than or equal to positive 4. The domain and range of inverse function f of x. The domain is a set of real numbers such that negative 3 is lesser than or equal to x, then x is lesser than or equal to positive 4. And the range is a set of real numbers such that negative 2 is lesser than or equal to y, then y is lesser than or equal to positive 1.5. Comparing the domain and range of function f of x and its inverse function, the domain of function is the range of its inverse function. The range of function is the domain of its inverse function. Example number 2. Observe the graph of function g of x, which is the cube root of x plus 1 and its inverse function. Applying the steps in finding the inverse of one-to-one function, the inverse function of g of x is x cubed minus 1. Then, draw the graph of function g of x and its inverse function. The graph of function g of x is asymptotic along the vertical axis, and the graph of its inverse function is asymptotic along the horizontal axis. The reflection of the graph of function g of x is the graph of its inverse function. The domain of the graph are values taken along the horizontal axis, and the domain is represented by the graph of inverse function g of x. Why? Because the domain of the inverse function reaches negative to positive infinity as compared to the domain of function that approaches negative 2 to positive 2. And the domain is a set of all real numbers. Now, the range of the graph. These are values taken along the vertical axis, and the range is represented by the graph of function g of x. Why? Because the range of function reaches negative infinity to positive infinity as compared to the range of inverse function that approaches negative 2 to positive 2. And the range is a set of all real numbers. To summarize the domain and range of function g of x and its inverse function, in the function g of x, the domain is a set of real numbers such that negative 2 is lesser than or equal to x, then x is lesser than or equal to positive 2. And the range is a set of all real numbers. Now, the domain and range of inverse function g of x. The domain is a set of all real numbers, and the range is a set of real numbers such that negative 2 is lesser than or equal to y, then y is lesser than or equal to positive 2. Comparing the domain and range of function g of x and its inverse function, the domain is the range of its inverse function. The range of function is the domain of its inverse function.
To summarize the lesson, first, a function is one-to-one if it has an inverse function. Second, a graph is one-to-one if the horizontal line and the vertical line intersect the graph at one point. And third, comparing the graph of function and its inverse function, the domain of function is the range of its inverse function. The range of function is the domain of its inverse function. Now, let's it's your turn, dear learners, to answer those activities prepared in your learning activity sheet. See you again on the next episode, only here at DepEd MP TV. Bye for now.